Good morning, everyone. It's 9 a.m. sharp, so I hope that all the speakers and moderators are already in the room. So kindly just turn on your camera before we start our event, please. We have also sent out the virtual background for your perusal, so if you could also switch into that particular background will be much appreciated. Thank you. For IT team, could you please share the pads for today before we begin the presentation, please? Thank you. With that, I will hand over the sessions to our moderator today, Mr. Hanaga Simamrata.
Hello.
And before we begin, we would like to invite Dr. Erlangga Septama for the opening sessions.
Okay, thank you so much, Pak Grandika and Mas Hanaga. Good morning, everyone. We're hoping to find you well and everyone is in a good health and probably have a time to do some exercise and warm up in this beautiful morning before this session. Today webinar's topic is the gas exploration and development in Natuna Basin heats up what lies beneath. The title is quite a nail-biter, I say, and provocative at the same time. Although likely a bit rhetorical, well, everyone knew exactly what is stored beneath, and most of us maybe agree that sleeping giant is possibly lying beneath Natuna. Natuna Basin is a giant reserve, possibly one of the largest reserves in Southeast Asia. If I'm not wrong, it is discovered in 1973. But ever since it was found until now, which is almost 49 years after, most of the carbonate reservoir coverage was never commercial to produce due to the carbon dioxide content of around 71%. And last year or this year, we got a good news that the new exploration effort and campaign also find a gas from a siliciclastic reservoir that is clean from carbon dioxide and also hydrogen sulfide that could be produced commercially, hopefully. And I think the new hope has born, and this is inspirational. Today, present with us some of the best expertise and oil and gas practitioners that maybe everyone already knew, who have a very deep knowledge about the area, either in the exploration or in development. I'm very honored to welcome Pa Arya Disiona from SKK Migas, Pa Amir Mahmud from Conrad Energy, Pa Yan Yantriana from Medco, Pa Eko Wibowo from Medco, and Pa Budiono from. And also, last but not least, Mas Hanaga Simabrata. I don't call him Pa. I call him Mas because I think he's still young, from Colorado School of Mines, who will lead this discussion this morning. Wishing that the presentation will spark a constructive discussion and hopefully will inspire a new idea and to keep the Natuna Basins hits up, just like the title of this session. Thank you so much and enjoy the talk. I've give it the floor back to the moderator. Mas Hanaga, the times is yours. Thank you so much.
Thank you. Bapak Erlangga, thank you. Hello, everyone. My name is Hanaga, and I will be your moderator for the next 2 or 3 hours. And this topic is actually kind of personal to me because I actually have a bit of experience in the West Natuna Basin. Awesome people, awesome geology, and awesome data sets. Actually, if you, especially the seismic, probably the most beautiful I've ever seen so far. So if you're a student, go ahead and try to land an internship or a job there, and it's gonna blow your minds away. So for today's talk, we have 5 speakers, all of which are experts in the industry, and we have about 100 years of combined experience. And imagine the wealth of knowledge and insights that we'll take home today. And the first 4 speakers will present the gas potential in the basin from location to locations, and then the last presenter will wrap everything up. I would like to first give gentle reminder for the speakers that the time is about 20 minutes, give or take. And for the audience, if you guys have any questions, please drop those in the chat box, right? Let me let me show you. So if you can see my chat there, if you want to ask your question to a specific speaker, you can probably include their name. Otherwise, we'll assume everything can just jump in and give their opinion. Please remain muted for the non-speaker. Okay, so I'll just go ahead and introduce our first speaker today. Next slide, please. Mas Yan Triana. He earned his bachelor degree in '93 from Universitas Pajajaran, and then his Master of Science in Geology from Texas A&M in 2000. He has over 20 years of experience combined and joined Medco in 2020. And he's currently the manager offshore exploration in Medco Indonesia. So Bang Yayan, the floor is yours. Thanks.
Okay, thank you. Let me share my slide first. Can you see the slide now?
All good.
All good, okay. First of all, I would like to thank you for this opportunity to me presenting this ocean basin, like Hanaga said. And the Natuna is very prolific. We can see later on. Also, in this opportunity, I would like to express my apology because I think my knowledge about this basin is probably I'm the youngest on this, so not really deep as maybe you thought. Okay, why it is Natuna? First, I would like to show you the interesting of the Natuna. Yeah, it's the pointer. Okay, so this is the regional basement time structure map. If you see the one that the deep color representing deep, the one with the light color representing it is shallow. Yeah, the West Natuna itself in here, the East Natuna in the eastern part. So between west and east, divided by the Natuna Arc, which is a paleo high. Interesting fact in this Natuna is that currently there is around 13 blocks holder with total acreage around 37,000 square kilometers, very extensive, very large. This basin is also explored since 1970s with the oldest, I think, is Natuna C block block B is 1968 and block A in 1979. So this is very old basin, then heavily explored. Current days, there is a total of around 67 fields discovered. And as you know as well, if you go to the east, Natuna, there is a super giant discovery named Natuna de Alpa that currently remain undeveloped due to the high CO2. And if you talk about the 2P reserve, from the start of 1970 up to now, we can see around about 1,031 MMBO with around 54 TCF. So a total is around 9,980 million barrel oil equivalent. So both combined is Natuna and West Natuna is very prolific. You see this number, but please bear in mind that this is combined. So the TCF number is coming as well with the Natuna de Alpa, which is the one that holding the biggest. If you take out the Natuna de Alpa, for example, it will be reduced about, let's say, 30% of it. But looking at that, the number is still quite large. Yeah. I'll go ahead with the other slide. Why it is prolific, you can see here in this cross-section. This is a very simple schematic cross-section in the region of the West Natuna from the north west to the southeast, oriented this line according to my cursor. You can see that this is very interesting geology. That is yet also simple, but in the simple world, there's always sophisticated things. So if you take a look from here, there is petroleum system element. The source rock is provided by the extensional technique that create half-graben system with non-marine sediment as the main source rock. Also, we recognize other source rock as coaly shales of the lower Arang, which probably might become a productive source rock in some area where the heat is enough to cook that source rock. On top of it, there is also one of the new thought that Muda, which is the youngest structure, the youngest sedimentary rock here, can be active as the bacterial gas potential. In terms of trap, you can see there is a compressional inversion created some kind of the four-way or three-way deep closure system here. And the trap, the compressional as well, help migrate the hydrocarbon from the kitchen up to the trap. Reservoir, you name it, multi-layer stack sand deposit in the non-marine, transitional, and the marine sediment in this area. And the seal, there is intraformational seals. There is a post-rip marine sediment, create seal for the hydrocarbon accumulation. So basically, there is a regional seal here, as well as there is intraformational shales that become seal for this hydrocarbon trapping system. You probably notice here as well, there is some of the high paleo high basement, as you can see here, but unfortunately we haven't really seen this basement to be fractured heavily, since the region is relatively quiet in terms of the tectonic. However, some deep paleo high here, for example, probably can provide some kind of a new play, what we call is a basement replay, for example. So we talk about the plastic reservoir on top of basement that create the four-way deep closure. Other than that, some stratigraphic probably occur as well. As you can see to the right of the schematic, there is some of the sin rip that is pinching out toward the high basement. This probably can become a new play in the area. I'll go to the next slide. Okay, this is about the statistic on the area. Apologize that this is probably not up-to-date data, since this is coming from scouting data Wood Mackenzie by 2020. So it's probably missing around 2 years or 3 years. But in general, the figure is not really changed. As you can see here, the exploration began in around 1970s. The first or the second or the early discoveries come from North Belut and Udang, and then go up to Anua, I think around 1980. And then one of the biggest is Belida. Belida is around between 1987 or something. So they create jumping in terms of the to be reserved here. However, after the 20, if you take a look, the creaming curve is relatively flat, meaning that there is some discoveries, but in terms of the resources, it's not really big. The basin is probably explored, marked by the offshore seismic technology by 1970, since before that, all the exploration concentrated in the onshore area. If you take a look in terms of the gas versus oil, if you take a look here, the one that discovered is more gas domination around 60%. In this statistic, I also exclude Natuna de Alba. Otherwise, if the Natuna de Alba join to this statistic, it will make the others too small. So that's why in this presentation, I try to exclude the Alba. The figure to the right, you can see the West Natuna Basin annual average production. If you take a look at that, the oil produced early, because maybe at the time, all the company or all the operator focused to deliver oil, and then gas start to go since 2000, since year 2000. As you can see, the peak of the oil production happening in around 95 with the approximately 160,000 barrel oil per day, which is quite significant. For the gas, if you take a look, the peak is around, I think, 160,000 MCF. So cumulative production estimated currently is around 3.4 this year. However, if you take a look at the end of the figure, it looks to be a sharp decline. When we put the straight line with the constant decline curve, you can see that the remaining is around 50 million barrel oil plus 900 BCF of gas. This is assuming if we do nothing. That is why I think exploration is very important to be conducted in this basin. So continuous exploration activities will be very help to delay the decline or probably make it more gentle. Next slide. I would like to highlight what we have done so far. In the area that we operated, Block B, which is very old PSC, we had numerous oil and gas field surrounding. In 2020, we conducted extensive activities by appraising old stranded discoveries. Of course, when we evaluate that, we try to use the new approach with the new view, and by this approach, successfully bring this approach close to production. There was a total of 4 appraisal wells with total around 160 operation day executed successfully and safely. Around that, there is a 14 DST performed with significant combined rates, more than or close about 200 MMCF per day, with around 3,000, more than 3,000 barrel oil per day. That's from combined total rates from 14 DST. So in that evaluation, because this is the offshore opportunity where we need to be cost effective to be able to keep the commerciality of the opportunity, we are trying to do the fit-to-purpose data acquisition. It means that we're trying to get what we need, we really need to have in order to move it further for development requirement. By this effort, we are securing significant in-place resources or changes resources or prospective resource to reserve for near production. So as you see, that's on the table. It's 4 well, operation days around 160, and I think the footage is also significant. All right. Other than that, we are trying to see what is a new play in the region. This is a seismic section oriented northwest southeast in one of the well that I mentioned before. As you can see here, there is a new play, a very young play that previously considered as a shallow drilling hazard. So in the past, people had kind of opportunity. But since we are also dealing with something that material that we need to appraise this more. So we change our mindset from a shallow drilling hazard to be able to see how big is the potential for that. It is resulted in a methane-rich gas. Probably it is bacterial trapped in a shallow plastic reservoir. As this is very shallow, then relatively low pressure, and some of the reservoir looks to be less compacted. In terms of seismic, as you can see here, this is a very good seismic feature. As you can see, this is amplitude driven and seismically recognized. And this opportunity is not only this one. Yeah, we can see in the basin there are some numerous features like this, but I think in terms of the resources, we need to be careful because with the low pressure, then we are dealing with probably low recovery factor, and also we can see that probably this is need more development wells rather than the deep reservoir. You can see here in the logs as well. There is a gamma ray log here, and then resistivity and also tonicity crossover. We can see that this gas opportunity it has a reservoir that relatively thick enough for production. You can see also the picture there when we test the well. It's flow with sustainable rates, and in terms of the number, I think that is enough for us to evaluate further. So what is the opportunity and challenge? In the Natuna, as we know, this is a prolific and had been heavily explored. Therefore, new ideas on exploring this basin is required, as we mentioned before. There are some untested, you can say, untested play, which is probably in this case is stratigraphic trap, basement drop play, or probably the basement fracture play. So the company, beside we are trying to investigate a new play, we need to make the profit by balancing with recycling. What I said is recycling or discovery. It is quite fun actually to do recycling or discovery. Why? Because this is something that already found, but we need to know how big it is. We need to know how to develop that opportunity in proper way so we can get the benefit of that. So what we need to do in the recycling process, of course, first is a new perspective. Old standard gas is probably not worth it in the past, but now since some of the new technologies also coming, new development concept we also can play, and the nearby facilities is also present, and can see the perspective that this could be worth to be followed. In the process, we also need to involve a multidisciplinary approach, meaning that exploration cannot work itself. We need to be able to communicate openly with drilling. We need to set the discussion and intensive collaboration with surface facilities, with the reservoir engineer and other stakeholders. With that, we can get the way out and how to to commercialize or to make this stranded discovery to be closer to production. Applying cutting-edge technology is probably worth it, of course, with balance with the cost efficiency. I would say that probably new seismic technology like PSDM reprocessing can give you a better basis for a decision or go to not go. As you see, the previous seismic section that I saw, that is one of the improvement from the seismic reprocessing, which is quite important to be able to understand, especially in a new play. That is a very good information as well to become a basis of further development. The fourth that I would like to highlight is the fit-to-purpose evaluation or data acquisition for further development. We found out that all the discoveries is probably not equipped with the new data set or the complete data set. Yeah. In the new well or the new appraisal well, we need to put the program that to fulfill all the requirements or the POD requirement or the PSC requirement. So we can minimize the number of wells in order to lower down the cost, and further with that we can see that the capital is less to be able to make the commerciality of this opportunity is enough for company interest. The other thing is probably need some collaborative action with neighbor. Neighbor here is can be the adjacent PSC or adjacent block. Also, we can probably collaborate with the cross country border. I think my colleague Eko will show you the condition of the East Natuna, which probably we need to collaborate with Malaysian border. The last one that I put it not here is that something that I think we need to propose. This is because there is area promise Kakamiga, so I'm trying to put this note that by nature, of course, offshore exploration and development is a risky business and require high capital. Therefore, I think incentive might help to attract investment in this area. We see that though yet to find in this area still quite big. Yeah, our estimate is probably around 1,500 million barrel oil equivalent, not yet to be found, but we probably not expect that number to be coming from a single discovery. It's probably more than around 20 plus discovery to be able to reach that number. So for that, we need to have to attract investment in this area. And why we put it at the blue font here, because I think this is something that we need to be proposed not only for the operator, but also to the government official. Last but not least, you see the cartoon here that in the past, to find oil and gas, just go out to the sea, find some gas, drill a big hole, bingo, sort it. Yeah? But this is a very simple process, which probably not work nowadays. This is only something in the past. However, for nowadays, we need to begin with the end in mind. This is from Stephen Covey, meaning that when we begin, we need to have a clear vision on what we try to achieve in the future. I think that's all from me. Thank you very much for listening.
Thank you, Bang Yan, for the awesome presentation. That's really interesting about the creaming curve and how what we can do to like heal or infigure the discovery or the reserve rate. But I'll summarize everything at the very end. So for now, we can move on to the next speaker. Thanks, Bang Yayan. Next slide, please. Okay. So the second speaker will be Bang Wibowo. Bang Eko earned his bachelor degree from the Department of Geology, Faculty of Earth Science and Technology in Institut Teknologi Bandung in 2000. And Bang Eko has over 16 years of experience combined. And he joined Medco since 2019 and has been with the company for about 3 years. He's currently the manager, renewal and exploration study at Medco. So Bang Eko, the floor is yours.
Okay, thank you, Pak Hanaga. Good morning, ladies and gentlemen. Let me try to display my screen first. You see my screen?
Awesome.
Yeah. Okay. Yeah. Good morning, ladies and gentlemen. Thank you very much for your attendance. Thank you very much also for the committee for this opportunity and also for arranging this webinar session. If previously Pak Yan already discussing about the West Natuna Basin, now I'll little bit move to the eastern part, which is East Natuna Basin. What I try to present today is an option to optimizing stranded gas discoveries in East Natuna. What's the opportunities and also the challenges. My presentation today will be a little bit general, but hopefully it could trigger more detailed discussion later on. Okay. Okay, first, let me reintroduce our operation, Medco operation in Natuna Basins. As mentioned before by Pak Yan, that we have a big old block in West Natuna Basins. It's Natuna Block B. I think it's one of the main producer in West Natuna Basin now. It's producing us about 250 million scf a day, plus about 12,000 barrel oil per day. And also in the eastern part, we have two blocks actually. The southern part actually is a part of Natuna Block B, is the same PSC. It's also an old block. We have already two discovery in here. The first one is Sokang discovery, is an old discovery. They discover gas in Miocene sandstone, Arang formation, is several hundred BCF with CO2 ranging start from only 5% until about 80%. We also active in this basin. In 2019, we drilled one well to explore Muda formation, apply Ocean sandstone. We drilled Tuna one well in 2019 in here. Yes, it's discovered gas, but unfortunately, CO2 is about more than 80%, but the gross resource is about almost 1 TCF. Okay, a little bit move to the northern part. We also have another one blocks in here, which is North Sokang block. We also have another gas discovery in here. It's already drilled by 4 wells. It's a Dara discovery, several hundred BCF, also from Muda Pliocene sandstones. The good things is the CO2 content is only 2%, less than 2%. So it's one of the potential of the sweet gas in East Natuna Basin. Other than that, on the Malaysian side, somewhere in the Malacca Strait, we also have conducted FTG about 55,000. So we are really serious to explore this basin. So hopefully we can get another commercial field in the near future. Okay, then I'll move to the another slides. I will a little bit talk about a little bit geological setting of this area. I'll start from this map on the left side. I got it from the GMG Petroleum in 2013. So this is the West Natuna Basin as previously presented by Pak Yan, and then this is a Natuna Arc, which we believe as old basement high, which and also separated West Natuna and East Natuna Basin. So basically, in general, East Natuna Basin is divided, if you could simplify it, into three geological province. On the northern part, if you can see here, the fault trends is mostly is as northeast southwest, like we found also in West Natuna basins. And we also observed some minor inversion, not as massive as in West Natuna Basin. It's a little bit milder, relatively milder in East Natuna Basin. Then we move to the central part, which is, we believe this one as a stable platform. We call it also Subishelf. And if we see to the next map in here, in this area is where the carbonates is massively developed. And also we have found Natuna de Alpha somewhere in here. Then moving to the southern part is quite different, where the carbonate is not developed anymore in here, while in this area is dominated by the major subsidence, very thick sediments. We call it bunguran trough, and this one we believe as the main source rock for the area. Okay, then we move to the next session. What kind of clay available in this area? So we try to simplify it actually. The play concept of the area is not a straight line composite geological sections, but is a combination from some arbitrary lines. For these sites, it's representing the northern part, which I mentioned before. There is some mild inversion. You can see here. I think later on maybe will be discussed more detail by Budiono from Premier Oil, which discover oil and gas in the Arang and Gabus formation. Then moving to here is a Natuna arc. We also observe some truncations, but I think it's a little bit challenging, more risky in terms of migration, because it's quite far from the kitchens. And moving to here, we have some isolated graben. We have in Komodo graben and also in Sokang trough in here. We discover gas in Miocene sandstones in this area, in this Miocene sandstones, which CO2 ranging is 5% until 80%. And we also observe some on-lap features in these basins, which probably quite interesting, yeah, since the basins already proved generated hydrocarbons. And moving to this part, actually is representing the Paus Ranai Ridge in here, which I think now under bidding round from Migas, yeah, we saw some basement high, old basement high, and surrounded by the proven kitchen. Yeah, so it's potential for the basement fractures. Also in the upside, I mean in the younger formation is already drilled by Paus wells and discover also gas in here. But unfortunately, again, is contains some high CO2. Then for this one, which is massive carbonate, is representing the stable platform located in here, is where the Natuna de Alpha is located, somewhere in here. Most of the discoveries is located in the basin margin here, but a little bit to the central, I mean the center of the core of the Subishelf is quite challenging in the migration, because many wells drilled in here is wet. Okay, then the last one is representing the Bunguran trough somewhere in here. So it's very thick sediments. It's major subsidence. You can see some fine clastic develop in here, some translation, rollover from the marine sediment we observe in this area. This area also where our data discovery is located. So actually there's a lot of play to be explored in here. The question is it already explored by previous companies? So I'll move to the next slides. So it's just exploration history highlights. I will try to highlight some activities what have been done in the basin. So the exploration actually already started about 50 years ago, 50 more years ago, which, as far as I know, at least already 55 wells exploration and appraisal wells drilling in the basins, which is from most of the wells, about 43 wells is drilled between 1970s until about early 80s. At that time, most big company, there's two companies in the northern part and the southern part, is try to explore the Trumbu limestone, which is very tempting carbonate features. There's a lot of well drills in here. And in the southern part, also a big structures of they're expecting for the Arang sandstones. As you can see here, there's a lot of gas discoveries as shown by symbol in the map in here. There's a lot of discoveries, but in the northern part, most of the discoveries located in the basin margin in here, while in the center part of the sub-shelf mostly is wet wells. Okay, most of them in the southern part especially is tested gas. Yeah, but again, it's a common issue that we have CO2 almost 96%. Yeah, as mentioned before, that the major discovery is a remarkable discovery is actually Natuna de Alpha, located in here. It has about 5,300 feet of gas pay, about 1,600 meters. Yeah, it's very thick of gas column, which some publication mention is have about 200 more TCF gas with CO2 about 72%. If I'm not mistaken, the recoverable net gas is about 46 TCF. Is such giant discoveries. Then exploration actually halted some gap between 1983 until about 2000. In 2000, another company is coming to test the actually Arang also and Muda formation. Then and they found some gas discovery in the Muda formation, located somewhere in here, Dara 1 and Dara 2, which have low CO2 content. So it's one of the potential. Then recently, after gap again from 2000 until 2014, about 14 years, more than 10 years gap in exploration. Nobody wants to drill in this basin. I think Premier start to re-explore the northern part area. And congratulations, they discover oil and gas in Gabus and Arang formation in the northern area. From this all discoveries, some is under appraisal now, but none of them have been producing now. So what is the challenge? Of course, we already know that the main challenge is CO2. Now, I try to discuss a little bit about CO2 distribution. Yeah. So start from the left map, you can see here, this is as a background is a maturity map for the base source rock intervals. From the gray one is representing the immature area. No wonder that's why most of the well drilling here is dry. And the green one representing the oil window. The pink one is a gas window, and the yellow one is over mature. What we can observe here is most of gas discoveries is located near the mature basin. That's why we believe this Bunguran Trough is the major kitchen area. And the square in here is representing the CO2 content of the wells. Yeah, so it's try to put in on the well basis, not on the interval basis, because it's too detailed if we want to discuss about in every interval. Yeah. So you can see here that most of them are red. Yeah, yes, because CO2 more than 50%, but some of them also have medium CO2 content, about 10 until 50%, about 40% somewhere in here. And the good one, we still have low CO2 content, less than 10%. After we evaluating, the most of the low CO2 content is actually found and discovered in the Pliocene Muda sandstones, which is very young sediment. This is quite potential. Then the question is it Muda sandstone? We are sure that we will have low CO2 content. Unfortunately not, because based on what we drill in Tuna, we drill also discover try to explore the Muda formation, we have CO2 then 80%. But we learn a lot from these wells. Actually, there's a clue for the CO2 content, what we can see in this seismic session. Actually, if we have CO2, some seismic features could help us to reduce the risk of the CO2. We call it as a Christmas tree, because it looks like a Christmas tree. In this example well, we see that most of the section, penetrating the Christmas tree have high CO2. But in here, which not it's not intruded by the Christmas tree. It has low CO2 content. But of course, it's difficult. It's very challenging to define it on the 2D seismic data. That's why my point is 3D is very required to predict the CO2 distribution, because after we map this seismic feature, we can see that this is the distribution of the Christmas tree. So we have opportunity in the rest of the structure. Okay, that's for the CO2. So point here, we still have opportunity in the Muda, Pliocene sandstone for the low CO2 content, and we could help to reduce the risk by 3D seismic data to identify some seismic features like Christmas tree, and the other one is actually a halo effect, which I could not describe in this presentation. Okay, then how about the high CO2 content? Doesn't have any value at all? The question, of course not, yeah, because I got a disclaimer for the first one. I'm not expert in this CCS technology, but I got it from King et al. In 2019. There's some actually 6 options based on King that for geological storage for CO2. Well, I will not read one by one, but I'll try to emphasize the depleted oil and gas reservoirs, which is in East Natuna. We still don't have it, but we could have it in the near future. But what we already have it now is actually a deep unused saline water saturated reservoir rocks. I'll try to remind again for the Natuna de Alpha discovery. This is the Trumbu limestone. It's about 1,600 meter column hydrocarbon gas, and the seal by Muda formation. So what we have already now is actually a proven seal. We have, of course, significant gas resources. Clean methane is about 40-60 CF, and we already have also the proven seal capacity, which could seal until 1,600. And if you remember before, as I mentioned before, that we have several dry hole located in here, which is actually the same place. Yeah. So we have already the reservoir, which is of course is saline because it's deposited in marine deposit. Then we have also proven seal, which potential for geological storage. Okay, then the idea is we can produce from the Natuna de Alpha in here and inject the CO2 into the proven wet reservoir somewhere in here, because we already have resource. Means that we could save the exploration cost, and we could learn a lot about the storage capacity based on well available in this area, which is the same play with Natuna de Alpha. Okay, now I'll try to summarize what I have discussed today. Okay, this is what we can summarize for the opportunities and challenge. I've proposed for the staging development. Let's say it's like that. So we have in here is a data discovery is 2% CO2, right? And somewhere in here and in here we have a medium CO2 content. It's about 40 something CO2, but the resource is TCF for both. Yeah. So in here we have several hundred VCF of clean gas, only 2% CO2. The idea is, how about if we blend this gas with the discovery? Okay, then we send it to the West Natuna Basin. As we know that gas price in West Natuna Basin, I think it's one of the best gas price in Indonesia. This blending technology, I think, if I'm not mistaken, please correct me later on if I'm wrong, is also proven in Malaysian side. They're blending the gas and they can sell it to the market. So we have good gas price in here. We can blend the gas and send it to the West Natuna. Is for the first stage. Later on, after it's depleted, as we know, we have a big discovery in it. It's 46 TCF net gas. Yeah. So it become a depleted reservoir, saline. So we can inject the gas from Natuna the alpha to here, and also we can sell, and of course it could be blend later on until the certain amount of CO2 content, and can sell it to the West Natuna Basin. So I believe that if we decide to create floating LNG from the first time, this will be difficult because it's very high capital, right? But if we perform like multi-staging development, starting from the medium CO2 content combined with the low CO2 content, after it flow, it's proven, then Natuna the alpha, we can reduce the cost of the exploration well because it's already appraised by 4 wells, 5 wells. So we just can produce it and re-inject after it's depleted. If it's not sufficient enough, we can inject also to the some wet wells located in here. So if we could build the pipeline from East Natuna to West Natuna, besides in Indonesia, as we also know that in Malaysian side, in different side of our country, our neighboring country, there's also a gas discovery which is facing the same problem, actually, the commerciality. It's not sufficient enough, it's not economic enough to be developed, because there's no facility at all, the same like us. So we can also absorb this discovery to the facility in here, so we can sell also to the West Natuna Basin. So this is the opportunity. I'll try to emphasize again that is a sizable sweet and sour gas discovery, potential for blending, and also we know that already have market in ini, which is in West Natuna Basin, which is have a good gas price, then also potential cross-country border gas monetization, and also as mentioned before, this potential for geological storage for CO2 because we have wet saline reservoir in here. The challenge is a classic issue. We don't have any infrastructure. Of course, it needs very high capitals to develop it, and commerciality maybe some companies a little bit doubt to develop it because it's very high capital. But I believe if fiscal term, maybe it could be stimulated by fiscal term and investment credit. I don't know for sure, but it could attract a company to develop this potential gas discovery. And of course, the last challenge is, as we know, that CCS technology is very early stage. We don't have, I think, in Indonesia proven CCS technology applied in the area. Please correct me if I'm wrong later on. Okay, I think that's all my presentation. Hopefully it could trigger more detailed discussion later on. Thank you, Pak Naga. Back to you.
Thank you, Bang Eko. That's really interesting. So I think one of the key to tap into the Natuna Basin's gas is to be creative with your CO2. That's the keyword of the day. Before we proceed with the third speaker, so how about we take 10 minutes break and let's be back here at about 10:10. How about that? So see you guys in 10 minutes. Hello. 1 more minute probably, and then we'll go with the next speaker. So before that, I'd like to inform all of you that we are reaching the maximum numbers of participants. So for those of you who have friends who are interested in this forum, please forward the link, the YouTube link I copied in the chat box. Okay. So our next speaker today is Dr. Amir Muhammad. Next slide, please. Thanks. So Dr. Amir Mahmood earned his bachelor degree from the Karachi University in 2004 and subsequently his master in 2008 in the same university. And then certificates fourth frontline management at Monash University in 2014. And also his PhD in sedimentology, stratigraphy, basin analysis, and petroleum geology, also in Monash University in 2014. Dr. Amir has over 15 years of combined experience, joined Conrad in 2016, and has been with the company for about 6 years. He's currently the asset manager of Mako gas field and Duyung PSC in Conrad Energy Asia. Dr. Amir, the time is yours. Welcome.
Thank you, Anaga. I will share my screen. Yep, can you see, Hanaga, can you confirm if you can see the screen?
Oh, good. Awesome.
Thank you, Hanaga. Wonderful. First of all, I would like to thank you, a big thank you to ISPG for arranging the talk. I would also like to thank all the listeners who are joining on this weekend and Saturday morning. I'm pleasantly surprised that we have more than 100 people at the moment listening. Thank you very much. I hope I will not bore you and will try to show something awesome. As Hanaga mentioned, West Natuna and Natuna is awesome when you look at the subsurface, and hopefully we will look something interesting. I would also like to thank Pa'a Elanga, who already introduced the session. So let's keep going. What will I be talking about is where the Natuna Basin is, what the location is. You will keep on seeing it again and again, so I will not spend too much time on the regional and location bits. I will just try to show some of the stuff what Conrad is doing, and we'll try to follow the theme of this session, that what lies beneath. And the best way to do that is just by showing you some snapshots of what we see in the seismic and why we are so interested in this area. On the right hand side of your screen, you can see a map, which is very colorful. I did not put it there because there was empty space in the screen. I put it there so just to give you a perspective of the water depths. The different colors are showing the bathymetry. You can see the lands and the islands, Malaysia, Sumatra, Borneo, and in the north, it says South Asia, which is a mixture of Thailand and all. The square box or rectangle box is where the West Natuna Basin is. You can see just south of it, two islands or arcs. When you move towards the east, you see a dark blue color. This is the deep water South China Sea. We are going into deep water territory there. Most of the West Natuna and Natuna area, you can see, is relatively shallow water, and overall it's a very gentle slope towards the east. More on location. On the map, I will start right from the center of the map, where you can see the Natuna Arch. The Natuna Arch basically separates the West Natuna Basin and the East Natuna Basin. You have already heard Payayan on the West Natuna Basin and then Paeko on the East Natuna Basin. I think now, after hearing those presentations, when you look at this map, you can complete the whole picture, what you are looking at. The red line shows the political boundary. In the north, there is Vietnam. In the east, there is Malaysia. And on the west, there is again Malaysia. Interestingly, the Malay Basin sort of creeps into the West Natuna Basin. And in the southwest, there is Penyu Basin. Obviously, the geology is interlinked and connected of all the area. What are we looking at in Natuna? In the east, these are the Sokeng block, North and South Sokeng, Tuna PSC, and the cluster of West Natuna PSCs. The circle shows all the West Natuna where for last 30-40 years all the action is. On a regional level, it is a very busy map. You are looking at distribution of synrift sediments and distribution of source rock as well. This may be factually, there may be few things which needs to be updated, but overall to the regional geology, I think it is a very good introduction. And I will not go into huge details of technical understanding, but what I would like to highlight here are two structural or two tectonic trends, which I think we all should know. One is the northwest southeast trend, and you should be able to see on your screen what I mean by northeast southwest trend. And another one is the northwest southeast trend. So there are two major structural trends here. And I will continue and move to the next slide. It's a very nice paper, and you will see it again in my next slide, and I will give you the reference there. You see on the right hand side, there's a map with two cross sections, A prime, B prime, and then on the left hand side, you can see those cross sections. And what you can see here is how the basin and the structure is forming, and what is really holding the main known oil and gas accumulations, especially in West Natuna Basin. And I would like you to emphasize on the B prime. Going from the west to the east on the B prime cross section, you can see a series of anticline. First, from the west, you will see Anoa, then KH, KF, Anambas, Forel, Banalak, and Udang. And these are series of anticline. These are series of inversion structures. These are inversion anticlines, which are northeast, southwest in direction. And these are the inversion structures which hold most of the known accumulation in the West Natuna Basin. These are inversions, so these are compression events, different intensity of compression within the basin resulted in different intensity of inversion, and which you can see on this as well. And so when you move in different areas of West Natuna, when you move from one PSC to another, most of them have these inversion structure. What changes and varies is the intensity of the inversion. So you see a yellow star and a box just below Forel2. This is where the Duyong PSC is. And again, it is sitting on a significant inversion structure. Stratigraphy of West Natuna Basin. This is taken from Manur and Jacques 2014, and the previous slide was also from Manur's paper. Very nice paper. Anyone who is interested in getting an understanding of the regional structure for West Natuna should have a look at this paper. In the West Natuna, the stratigraphy starts from classic synrift sediments, which started to deposit in late Eocene time. It's known, these sediments are known as Lama formations, Beluth. Sometimes they are also known as Lower Gabus. Within West Natuna, although there are only 4 or 5 major players, but everyone is using a slight variation in the nomenclature. So it varies. What I call Lama, someone else may call Beluth. Anyway, a very thick package of sediment exists in the West Natuna Basin, moving from synrift to post-rift. And then there is a significant deposition of synrift or syn inversion, which is known as the Arang formation. And then when you go shallower, post-inversion, calm phase of the basin, when there was not much movement, there is deposition of Muda formation, which is a thick pile of shale, basically capping the whole of West Natuna. Within this Muda formation, there are sandy layers, which we call intra-Muda sands. These are the main reservoir for the Mako gas field. Now you can see some examples of the plays, different plays in different fields within the West Natuna Basin. Paeko or Payayan mentioned the new play in Muda formation. That is correct. That is the new play in West Natuna, and we are developing that play. It is quite significant. As I said, the sand varies in West Natuna, but how big of an inversion it is sitting on top makes the difference. So the structure size depends on the size of the inversion it is sitting on. Now let's move to Duyong PSC, and I will now show you a series of seismic, just to give you a flavor of the theme of this topic, that what lies beneath. So just to give you a flavor, what really lies beneath the subsurface. This is a regional 2D line which goes from Duyong PSC up to the northwest, now so-called an Anambas PSC. And what you can see is on the right-hand side, it says Mako inversion. This is a huge inversion structure. And on top, you see a square box. This is where the Mako field is. And this is the Muda formation. And within that, you see the intra-Muda sands. So it is a large four-way structure which hosts the Mako gas field. We call it Mako structure. And this structure was formed due to the inversion. So it's a large four-way antique line. What other types of play are there? There are Arang to lower Gabus ranges plays. There is Upper Gabus, Miocene, sandstone, which are subcropping at the Muda unconformity. There are Gabus sands which are draping onto the basement. And there are classic sin rift traps as well in this area. And in my opinion, this geology or these play types are not only for the Duyong PSC. This is a representation of the whole play types in the West Natuna area. Starting from the deep, within the Lama and Benua formations, there are classic sin rift packages, which have, we think, proper traps. These are early stage alluvial fans that were formed on the rift opening. So we call them Lama formation, and they are thick packages, and we can map them within our area. There are thick packages of what we believe are well-developed alluvial fans. We also believe that due to the close proximity to the source rock, they are very good targets in the area. These are deep targets. When I say deep, we are talking about 13 to 14,000 feet. Moving slightly higher in the package, Gabus formation are again, these are well-known plays within the West Natuna Basin. And what you can see on the seismic is again a classic sin rift opening, a wedge-shaped package right in the center. And then you have these range falls going up to Arang formation. And in that whole process, there are potential traps throughout the sequence. There are some direct hydrocarbon indicators there as well. This is a classic image of the possible traps in the West Natuna area. Coming to more interesting stuff, or what I like more, is on your screen you can see a RGB blend of the Arang formation, and this is within the Duyong PSC, but again it is a representation of what you see in the West Natuna Basin. These are very well developed meandering channels, which has point bars in between. You can easily differentiate the channel sands from the mud-filled channels. And there's a series of, as you go throughout the Arang formation, you can even see how the channels were moving, and you can map the channel avulsion in there. So As Hanaga was saying, this is for a geologist, this is like looking at a textbook, and this is dream coming true, looking at this kind of quality of geology on seismic. Again, same thing which I was showing on the previous slide. You can see the lobes of Arang formation. There are direct hydrocarbon indicators in these sands. These well could be gas. Very well developed point bars, which can be differentiated from the rest of the sediments. Similar fields are being produced in Malaysia, in the Malay Basin. Shallowest section of the basin, Muda Formation. Duyong PSC is developing the Meko field, which is within the shallowest portion, so it is a new play. What you are looking at is a standard seismic section. You can clearly see the amplitude shut off on the gas water contacts. So the seismic here plays a very important role. And this is a classic large scale rift fill system. So you have a rift opening, and I'm talking in a sedimentation terms. You have a rift valley opening, and then you have heap of sedimentation. The sand is being distributed all across the graben, and later the sand is charged by biogenic gas because there is a big package of shale within the formation. Just for reference, for scale, the feature you are looking at in front of you, just the bright amplitudes are about 12 to 14 kilometers. So it is large, it is significant in terms of size. What are the challenges when you are looking at a shallow reservoir like this? From a geological perspective, cutting a core is the most challenging thing, and you want to have a core to do all the good stuff or all the good geology on that. So Conrad did a lot of planning on how to successfully acquire cores in this shallow package. Within West Natuna, there are not at all any conventional core in the Muda formation or in the intra-Muda sand. And we believe still we have the largest depository of intra-Muda sand cores. And how do we do that? Is a lot of planning. The planning starts from where we will start cutting the core, which is the trickiest part. If you start cutting the core in the cap rock too early, then the sands are so soft and friable, they are not able to push the cap rock and the barrel jams, and you will not collect anything. If you start cutting the core too late within the reservoir, the sand is so friable that you lose all the fabric and everything goes, get messy in the barrel. So it starts from planning the right equipment, rate of penetration, circulations, mud, using a proper closed catching system. So in the barrel, you need to have a closing system so you don't lose your sand. You have to treat the core with love. You cannot move it around. We use a special sliding system, so there are no bumps. Once the core comes out from the hole, you lay it down on a stage, so just to save it from bumps. You cut the core in meter intervals, but you leave it in the inner barrel, and then you inject it with foam. And the idea of injecting foam is just to give it extra cushion within the core barrel, so that the fabric stays in situ. So there is no loose sand that is moving around while it is moving from the well site to a lab. What happens at the lab? You freeze it. You freeze the barrels. You put them in freezer, and you can see all the frosting on the cores. And then you cut open a section on the fiberglass core barrel, which is the inner core barrel, and using a plunging methodology, it's called plunge, heat, and shrink method, you take the core out. It is a delicate operation, and at the end you end up with a core plug, which is a conventional core plug, which looks right as you see on the right hand side. Once you have a conventional core plug like this, you can do all the good geology, conventional porosity, permeability stuff in the lab, which is all normal. What do you do with that? I just wanted to show why this is important. And I am showing here an example of the intramuda sand at Mako. You want to confirm what you see on your logs, and you have to confirm this from a lab perspective. The sands are in a range or in an order of 7 to 8 darcies and 30 to 34% effective porosity. It is very good quality sand, and you want to confirm it. So you need to treat it properly. What else can you do? You can obviously do your core analysis, the positional environment, all the general subsurface standard studies. You can do thin section studies. This is again a sample of thin section we have in intramuda sand. The blue area shows the porous areas. You can see it is excellent intragranular porosity. You can also go into do your SEM to see the pore throats and some more chemistry. And here some interesting features which you see right on the right hand side are your framboidal pyrites and siderite, which we know this is the shallowest part of the basin, so it's still in early diagenesis phase. I hope I have shown you regional stuff, then coming to PSC level, to core, and then micro, and zooming into SEM. So I hope I have entertained you. This is what I'm hoping. At the end, I will also show just one slide on what is the gas composition in West Natuna. So it's a combination of some of the internal study we did at Conrad, and this is done by my colleague Radhi Mohammed. It's a combination of biogenic and thermogenic gas in most of the West Natuna. What I would like to highlight here is that in West Natuna, there is CO2, but it always stays below 7-8%. Whereas in the East Natuna, as we saw, it is quite high. And the major factor is in East Natuna, there are a lot of carbonates, whereas on the left-hand side or on the West Natuna area, there are no carbonates. So I think carbonate plays an important role. Moving forward and to the closing remarks, There's a famous scientist, an American one, astronomist. His name is Percival Lowell. He was one of the early scientists who was working on Mars and Pluto. And he produced some maps in the early 1900s, which shows canals and roads on the surface of Mars. And on the right hand side below, you can see one of his drawings where he shows the roads and canals on the surface of Mars. Later, it was found that what he was seeing was correct, but he had some scratches on the lens of his telescope. So he reported, he thought these are roads and canals, but in reality, they were just scratches on his lens. So takeaway messages. The real voyage of discovery consists not in seeking new landscape, but having a new set of eyes. So what I want to highlight is be aware of your biases. When we are working, for example, especially in West Natuna, we think that we have been producing for last 40 years and new discoveries are not possible. I strongly believe that we have to break that stigma. There are still opportunities. There are still classic formations, classic traps that are present, which we need to chase within the deeper section. It may be Lama, Benua, or right in the center, or stratigraphic plays as well. Thank you. That's all from my side.
Thank you, Pak Amir, for the interesting presentation. Thank you for showing the seismic. I told you guys, it's awesome. Okay, and also the thin section, I really like it. But so let's for now move on to the fourth speaker, Budiono. He earned his Master in Geological Sciences from the University of Texas, Austin in 2002. Has over 25 years of combined experience, joined the Premier Oil in 2008, and has been with the company for about 14 years. He's currently the Senior Manager, Subsurface at Premier Oil Indonesia. Bang Budiono, the floor is yours.
So let me share my screen first then. So is it, you can see it okay, Jens?
Looks awesome, legit.
Thank you. So again, thank you very much for inviting us, Basque, to this beautiful forum. I learned a lot from others as well in terms of what they've done, what they've learned, and all those discussions. Basically, that's quite interesting. I've been in the area quite some time, so I saw many things happening, happening as well. So how the industry changed and all this stuff. The good thing about staying in one place for sometimes is you experience all those different kind of like events, and then certainly with my 20-something experience, especially in this basin, I enjoy my exploration time as well as my time working on the producing assets, basically managing the producing asset, combine all those together, the knowledge, and creating certainly a more self-satisfactory basically for your scientific interest. Again, in the introduction, it was mentioned that I was graduated from UT Austin, but it wasn't mentioned that I was graduated from ITB as well. I'm proud of being part of the ITB graduate, so that was missed, so that's fine. So for the next few slides, I don't have that much slide actually. I meant to show you guys, but hopefully this gonna give a little bit different perspectives from previous presentations, showing all those subsurface part, all the beautiful seismic, how the place works and how you explore, and then what is the potential lies out there. So I'm going to touch a bit here and there because of the my experience, basically in the basin, is quite a wider range in that case. So first of all, I would like to introduce my employer, my current employer, which is Premier Oil Indonesia. It's just recently acquired by a bigger company called a Harbour Energy Company that's based in London, basically operating a lot of assets, basically in the UK, and then of course part of that acquisition, Indonesian Premier Oil Indonesia is part of the Harbour Energy Company, and then we used to be a major contributor to the company's production, but with Harbour Energy, Indonesian business unit probably only participate at less than 5% of the net production to the Harbour Energy. So currently Harbour Energy is producing something like 200 plus thousand barrels a day net to the company. So imagine, I mean, this is an aging asset, declining asset. So you might see something different coming from this side as well. So in that token, I mean, so exploration is kind of like playing a big part as well into this area, because without the exploration, I think just relying on the declining asset, we will not go anywhere. So in that case, we Premier Oil as a company is trying our best to find new resources, new prospects and all those stuff, and try to develop that, and that's proven to be happening. And as you can see, this is the map showing our operating area. As you can see, that red circles, that's what we are going to talk today about, the Natuna Basin. So as you can see on the circle, I think we do have two areas, the working areas. One is Natuna Sea Block A, to the left of that circle, and then to the right of that circle, we also have a tuna development basically coming from those. And then not to mention as well, we are exploring in the Andaman Sea as well. If you go to the west, I mean, on the map, not Aceh area, we are exploring as well deep water plays basically in that area. Hopefully by mid this year, we can see something, the result of the first exploration well in block as well. So again, my introduction saying that we've been around. So in that case, we will talk about what we enjoy so far within the blocks. I mean, because without knowing what you actually enjoy, what you're going to enjoy, basically exploring this area, you probably will not be interested in the area, because it's been declining, it's been explored, it's been exploited as well quite some time. So what's left? But again, I'll show you a little bit about our history and then why we need to explore more, because it's quite enjoyable. It's not just for us as a contractor, but as well as for the Indonesian government as well. So in the next slide, like I just said, I mean, to love something, you need to know what you enjoy, what you will enjoy as well. This is our history basically in the area. So we have been operating the Natuna Block A since 1997 and then 1996. It was taken over from Amosis. The first field developed and produced it. It's actually Anwar field, which produced oil since 1990. So taken over in 1996, 1997, we converted it to a gas producing field, and then since 2001, I think we've been exporting gas. We completely changed the field to the gas field, and then maintaining some of the oil production, because the oil production has been declining as well. So in that case, as you can see that, you can see from here that since 2002, let's say, 2001, when the first gas actually started, you can see that creeping up production starting from only 44 BCF. Now recently, I think we are keeping and maintaining our production at around 70, close to 80 BCF a year. So that's quite something, because with that, I think especially when people are talking about the high gas price, especially for GSA1, GSA2 is not that much different. The outlier is SAM gas. So in that case, you will see that, I mean, it's quite premium. I mean, you can generate quite a lot of gas. I mean, you can imagine that today's at $100 price, I think you can enjoy $17 of gas price, which is, you know, 1 BCF, that's equivalent to about $70 million. So that's quite a significant amount of money, I mean, to monetize the gas. As you can see that, I mean, the not just existing production, you can see that the to the right of that bars, actually, the bars is getting more colorful. That's because we're not just relying on the existing producers. We explore, we also appraise, and we also develop in that case. So that's why we can maintain, even increase our production since the beginning of this sales. So as you can imagine, I mean, that was quite successful. We've been producing this field since then, I mean, for the gas since 2001, and you can see that, I mean, cumulatively, I think we've been producing the gas for 1.5 TCF already. And that's something good, because this generate cash flow to the Indonesian government as well, the contractor as well. As of today, I think it's almost $7 billion we are contributing to the Indonesian government. So in that case, no question, I think having this 30 years production only from the gas, let's say 20 years production of gas, I think we contributing about $7 billion of revenue to the Indonesian government. And the picture around this graph is actually just showing you what facilities we have. So we currently have 7 producing fields. You can see that to the left bottom corner about our field laid out. And as you can see how the pipes connected between those, among those fields, and then connected to the export line goes to Singapore. And the rest of the picture, we have a 2 CPP, which is in Gajah Baru and Anoa, as well as unmanned platform in Pelikan Naga, and we also have 3 subsea developments we just recently completed back in 2019. So looking at this asset, we have all the spectrum. Basically, we have 30 plus years producing field. We have 6 years producing fields as well. We have 3 years producing field. We also have wells we just drilled a couple of months ago, even wells that we perforated, I mean, to test all the reservoirs, basically just months ago, probably weeks ago. That's our activities basically in this area. So it's quite complete, you know, spectrum of the activities basically in the block. So you can see that. I mean, you will enjoy when you're successful, and certainly you need to explore, I mean, before you can enjoy all this stuff. So that's very much from Natuna Block A, and certainly I think we, as I mentioned, we quite, you know, involved in all the activities, including what we call the production hopper. We inventorize the behind pipes, you know, preparing for the add perf from different wells, preparing the infill wells as well, find the where's the upset potential and unswept area, as well as even further, I mean, to compressor, to facilities enhancement, something like compressor wheeling and all this stuff. We plan all those, and then to enjoy all this, you know, beautiful results. Well, I think I'll move on to the next asset. Certainly, I will not, you know, show a lot of pictures that probably have presented before. That's probably you saw enough basically for those beautiful seismic underground things, and certainly I think, yeah, I'm going to show you a little bit about the surface and what we're going to do next. I'm going to touch on Tuna a little bit. This is showing you what Tuna is and how critical, how important it is. I'm probably just going to pretend that you know, in backward. I'm going to start from the bottom instead of from the top. So just catching your attention. Tuna is actually is quite critical geographic sensitive. That's what I'm saying. What does it mean? I mean, as you can see that the bottom right corner of the picture, there's you can see, I don't know if you can see my cursor, but that's country border line where Indonesia is. That's blue dot, the dash line. And at the same time, we also have that purple dash line. Somebody drawing this area and claim as well that this is part of their area. So that coincidentally actually covered that Tuna area where we are currently working. So that creates something, that creates some, you know, uncertainties, and of course some, you know, uncomfortness or something like that. because that's what's happening. I mean, the thing is, when we drill well here, I mean, they approach us. Basically, their course guard approach us, and then they try to intimidate us, and then certainly I think that's we responded that properly, and then certainly they stayed away. Problem is, I mean, that's claim will continue, and as of course, I mean, the most importantly, and for the Indonesian government actually to put something there, I mean, to claim that yes, I think we are operating this and this is our area. So that's why I think the development of this tuna area is quite sensitive, quite critical as well. I mean, for our Indonesian government territory guard. So that's why we are quite interested in helping Indonesian government as well to develop this. While at the same time, certainly, I mean, the contractor will not move until we know that exactly that we are making commercial development basically in the area. So going back to our discussion in this forum, especially for geoscience and engineering forum, I think I'm just going to give you a brief description about the tuna itself. So the tuna was discovered in 2014, drilling 2 wells. The well weren't tested, so that's the issues. And then the target reservoir, I think the previous speakers has already mentioned about those two different target, which is what Gabos, Arang, Lower Terumbu, and all those stuff. And then we drilled another 2 appraisal well basically last year, completed the test, and then it flowed very well. I think the test deliver 3 DSD tests, and then deliver about 40 million scf a day in total, plus probably around 10,000 barrels of liquid produced basically from those tests. So it's quite interesting, probably encouraging results. So with that in mind, so we come back, and then we certainly plan to develop this discoveries, and then hopefully, I mean, the plan for submitting the PUD is coming probably around October this year. Hopefully that we can achieve that. Talking about its development, it's quite complex. I mean, you'll see whatever you want to see there. I mean, because you have all the components there, including you have the gas, you have the oil, you have the condensate, you have the LPGs as well. You need to manage all those basically in the same development. Certainly, that's quite challenging as well. So overall, I think that's very much describe our development. But again, like what Yan mentioned earlier about well, it's going to be only like 900 BCF left in the basin, in the area. But hopefully, by having this development, at least we can contribute something, probably 400 BCF or something. That's probably our expectation. I mean, to add at least adding more reserves coming. Aside from that, by having this tuna developed, certainly the current plan is actually to sell that through to Vietnam through this existing facility next door. So hopefully by developing this tuna field, that will triggers other development as well. There might be some synergies can happen actually across the PSCs in the region. Well, I think as you can see that, I mean, this is quite challenging. I mean, to develop this and then deliver the gas up to the existing pipeline to the WNTS pipeline, that's going to take like 400 kilometers away. That's equivalent to probably around $400-500 million investment just for the pipelines. That's going to be challenging if we develop that way. So along the way between those 2 points, I think currently there's no new developments coming yet. So that's why I think the tuna development needs to carry its own development plan. That's pretty much about tuna. The next slide is probably my last slide. I will not dwell too much on this one. We discussed a lot about a lot of things about the exploration part. But the important thing about this is actually, well, I need to put disclaimer as well on this one. This is my personal view as the geoscientist in the area. As you can see that the future, the title is talking about the Natuna future exploration, and then certainly I think all you guys been talking about the classic Gabos and Arang formation, target, which been, like I said, producing since 80s, 90s or something like that. So no question, I think is the play works. And the only thing you need to, like Dr. Ami said, that you probably need a new eyes, I mean, to find those new prospect, new potential in the area. So just be more creative how you find things. So that's probably what we need in terms of existing and working place basically in the area. Mode of formation, I think, again, I mean, Conrad, our colleagues in Conrad has been trying to, develop this, and they have a successful exploration program. No question about that. Quite challenging operations, certainly with unconsolidated formation, low pressure, wide area. That's going to be a challenging development as well. But again, I mean, there's no time to, to complain. Let's do it, and then we support you guys. I mean, with the model development. See what can we learn basically from those other success or other experience. I jumped to the last one, Natuna de Alpha. It was touch base by Echo as well. That's a big accumulation. We don't know yet how to develop this. I mean, with this 72% CO2 content. So let's plug it there. Let's find the technology, and then let's go develop that. But the thing is, we learned something as well from our blogs that's worth sharing here is probably about the fractured reservoir. I haven't seen much about the presentation on this, but again, we had an experience. We have the evidence that llama formation or balut formation, in that case, whatever you call that. But again, this actually worked. The fractured llama formation, fractured balut formation actually works. And then we drill this well as an extended exploration from the development well down deeper to below the ANOA structures, and then found out that the Shin Rift actually there, the formation is as what expected. The rock is tight, 9% porosity with much low probability. But again, when you see the logs down in the middle bottom picture, you can see that, I mean, the logs doesn't show any crossover at all actually in the neutron density. You can see always a little bit like on the the resistivity. The gas showed a little bit, but where it probably comes, the gas, and then certainly with this, I mean, if you run a conventional petrophysics, it will not show up at all. So that's what dilemma when we drill the wells, and then we were at the point when we need to make the decision whether we want to test this or we declare this as a dry hole. So that's very much what we think. And then eventually, I think we also have a supporting data like image log that's supporting what we think. I mean, well, we see a lot of fractures here. Can we just test this? And then unfortunately, I think we have a support from management to test this. Although a lot of discussion happening, many of them actually against the idea of testing this interval. Fortunately, we have that test, and then it flowed quite well up to 17 million scav a day. And then that stopped there because this was limited by DST string, capability. And then, of course, this just to prove that it works. And the fact is, we put this in production, and then initially, I think this kind of reservoir can deliver up to 50 million scav a day initially from this fracture reservoir. Again, I mean, that works. And then the problem is, I mean, when we produce this, I mean, the containment is kind of like probably small, and then water encroaching quite rapidly. That killed the production earlier than what we thought. But again, like I said, for exploration, exploration is like us. I think this is a good thing to start, and let's find a bigger structure, more fractured area, and then let's explore it. And I believe they are out there that we can target for this fracture llama formation fracture reservoir. So with that in mind, as you are aware, I mean, llama is on lapping to the basement, most of it because it's Shin Rift sediments. So it's not impossible that we can find a basement as well if that fracture can be charged with the gas as well. I mean, in the area. So something like in the Vietnam or something that we can also chase. Problem is, where are those? I mean, where are those bigger llama formation fracture reservoir? Where are the fracture basement actually lies? That's something that for us actually as the geoscientists to pursue. I mean, to chase this and then add more reserves to the area and open up again the new play. Add resources, add production, and all those. So making the area is getting more and more interesting again. I think that's very much my presentation. I don't know, probably I'm taking too much time basically on this presentation, but hopefully that will you know, entertain your interest as well as triggering the critical thought about the exploring the area, as well as looking at a little bit of history about the how successful and how enjoyable if your exploration is actually success. I think that's very much from my side. Thank you very much for the time, and I hand it over to our moderator. Thank you.
Thank you, Bang Budiono. So Bang Budiono actually goes deeper, which is really interesting because previously we go shallow, and also other than technological obstacles, it's important to recognize the political side of the spectrum as well. So thank you, Bang. Let's move on to our last speaker, Bang Arya Disiona, graduated from the Department of Geology, Faculty of Earth Science and Technology from Institut Teknologi Bandung in '95. Has over 20 years of combined experience, joined SKK Migas since 2008, and is currently the Senior Manager, Gas Field Development in SKK Migas. Bang Arya, the floor is yours.
All right. Thank you for SPG for having me to present about the gas development in Natuna area. And now I'll try to share my point. Okay. Can you see my slide?
Yep, clear, loud and clear.
Okay. Okay. Probably I will elaborate several things that already explained with the previous presenters, and the four presenters already mentioned regarding about the history of exploration and what is the potential subsurface beneath of Natuna area. And Pak Budiono already mentioned about how it's challenging when we have exploration activity in the certain area, which is we have like a challenging position about the geopolitical area, and also I will explain about what the potential resources in Indonesia and the long-term plan regarding of the what we have in our resources, and of course we will have like a planning how to develop the gas in the Natuna area. And of course, because of we dealing with the gas hydrocarbon, we cannot only taking care in the upstream area, and of course we should to consider about the gas balance in the downstream position, because as you know that the gas commerciality is very unique. All right, this is Indonesia on the LN gas fact sheet that as you know that we have about 128 basin, which is based on our reserve status, remaining reserve status January 2021, that we have still have a remaining proven reserve about 2.4 billion barrel of oil and 43.6 TCF proven reserve. And we can see that what we have the facility of infrastructure in Indonesia, But if we focus on the Natuna area, as we can see that the legend of the color bar, we can see that in the middle of Natuna Basin, we have a producing basin, and we also known as the West Natuna area. And in East Natuna area, unfortunately, there is no producing field, but we have several drilling result and already presented by Mas Eko earlier. We have several challenging data that could be of influence about the strategic how to develop the gas in the East Natuna Basin. All right, and I just remind about the stratigraphic profile in the West Natuna Basin, and Amir already explained in more detail that we in West Natuna Basin we have very rich of reservoir characteristic, because of we know that this is depend on of the tectonic regime at the time. So the configuration of basin very different within different blocks. So sometime or somewhere we found in the block we found the prolific of balut formation. However, in the other block, we cannot find the balut formation reservoir, because as I mentioned that the configuration of the structure is very different. Okay, and this is the old version of structural plan in Natuna area. As you know that very quite different structural trend in the West Natuna area and East Natuna area. That's why the content of the reservoir is different as well. And in the West Natuna we have compressional inverted structure. However, in the East Natuna mostly has extensional structure. We have several of normal fault as a driven of the reservoir distribution. And in the West Natuna stratigraphic, as I mentioned, very quite different with the West Natuna, as you can see here that I took in a surrounding of Natuna de Alpha area, which is we have a very thick upper trumbu that the main reservoir in Natuna de Alpha field. However, in the below of Trumbu, we have also Aram formation, Barat formation, and Gabus formation, and also Muda formation in the shallow. And Pak Budiono in already mentioned and explained about the discovery history in tuna field, different with the Natuna de Alpha area. All right, this is the map that pointing about the remaining of gas field reserve status 2020. If we focus on the Natuna area, of course, this figure before the discovery of Anambas and the latest tuna field. So based on this figure, maybe you can you some that the reserve is very small. However, after we found recently of the hydrocarbon, probably maybe in the 2023 we have updated reserve status in Natuna area. And then below, I just to show you that we have several of facility regarding to support our gas development from the west to the east. We have like a LNG plant, mostly still active in the eastern of Indonesia. However, in the west area, we still have LNG, Arun LNG, and other pipeline facility. All right. In this slide, just to remind you that we have dream Indonesia, or government of Indonesia have dream that we should we can or we have a potential regarding our production profile in 2030, and you already known very well that there are in the gas production, there are several scheme. In the below one is what we have, what we call it like a strategic one, which is existing reserve. And what we have done is just you can see that if we do not have any effort to increase the production based on our undeveloped discovery or exploration, so the decline rate will be very sharp. And of course, this is very concerned with us as a government to increase our production and increase also the industry of oil and gas in Indonesia. And based on this strategy number 2, R2P is resource to production, is consists of the undeveloped discovery, consists of the future development. Probably we have still remaining reserve based on our existing, and we should have another strategy or another program to increase our production in our existing field. And the exploration activity, of course, we hope that a giant field discovery will improve our production until 12 BCF in 2030. All right. In order to achieve 1 million barrel per day oil and 12 BCF gas in 2030, of course, this is our achievement or our program, that if we need to achieve that dreams, so it's supposed to be that our reserve replacement ratio, meaning that we add the reserve, or we add the reserve based on the new program, new development, to recover what we produce based on the production. So the target of the reserve replacement ratio is should be more than 100%. However, in our KPI of Extramigas, we maintain 100% as the target. But in terms of our technical team to achieve that our dream in 2030, so we should have more than 100%. And in our notes or our note or our like a backup plan, we supposed to be should have around 150% of RRR. However, there are many of challenge to make it reality to achieve the 150, because like the simple one is we still have potential, but we need like a stimulus, like incentive or a change of fiscal term, and so on and so on. That's why for achieve that target, we need more effort than our usual business currently. And this is our achievement in 2021 is only 116% RRR. Okay, this slide honestly already mentioned with by Mas Budiono, but I just emphasize that this is our territory of Indonesia area, and the dash line is a claim by China that they claim this area still the territory. However, Indonesia already support Premier to make exploration activity in this block, and this is Natuna the Alpha field, and this is North Sokang operated by Medco. Based on this figure, as I mentioned by Pak Budiono, that in East Natuna Basin, there are many of challenges to develop gas in this area. So, in like in Natuna, like in Tuna, we have several strategy regarding to tie in existing pipeline in the West Natuna, or probably we can connect to Vietnam facility, because there are several possibility and shorter than connect to East West Natuna pipeline about 400 kilometer, and maybe to the north only several kilometers. All right. And the other thing is, as I mentioned earlier by Mas Eko, that why very rare activity in the East Natuna is because of there are many challenging of subsurface things, like high CO2 contents, ranging from 5% until 70 or 90%. So that's why the operator still calculate to create the strategy how to develop in the East Natuna area. Okay, and again, I will show you about the infrastructure or network gas map Indonesia. Maybe this is more detailed compared to previous slide. As you can see that for pipeline we have a belt pipeline network from East Java and probably connect to the West Java and until to Singapore or Batam and Tuna area. As I mentioned from previous slide, we still create the possibility about the design facility selection from the several potential strategy. And of course, if you see that in the eastern area more challenging, Indonesia, so probably we need more effort compared to the western area with the very established of infrastructure, especially in the western Natuna area. And of course, like I mentioned earlier in the presentation, that because of gas, hydrocarbon is very unique for development strategy because of the characteristic of gas itself. So we cannot stand alone with the upstream activity to develop of gas reservoir. However, we should calculate, we should mapping about the distribution of a gas balance in the surrounding area. And this slide, we can see that this national supply demand gas profile, and the bar information tell us about the demand sector divided into industry, export, electricity, housing, transportation, and petrochemical. And the line express to our supply And based on this line figure, if we see only based on the existing supply, so from now 2020 to the 2030, our existing field cannot supply the demands of Indonesian activity for the gas. However, we also calculate and open our book that we still have a potential project that we already approved by a POD or our near POD. We based on this project, we still have good news to fulfill our demand. And again, if we open bigger or further our book that based on our potential supply, of course, we still have more than much higher than the demand sector. But if we focus in Sumatra, Kepulauan Riau of West Java, and Natuna include in the Kepulauan Riau, the condition is not as the Indonesian figure or gas balance, because based on this figure, even though we have potential project or potential supply, it seems that we cannot any spare of the supply that's very for me is very dangerous, because we realize that the upcoming years the demand of the energy of the people probably higher than our expected. So in this figure, I encourage the industry of oil and gas industry to have high effort to fulfill the possibility demand of gas sector in Indonesia. And I think this is on my last slide. So the conclusion is that in Natuna area is already proven regarding about the subsurface hydrocarbon. However, there are many challenging in the eastern of Natuna. That's why we are now still create the strategy how to attract the investor, to attract our situation, to make it easy how to develop the gas field in East Natuna, instead of only the exploration activity. So that is my conclusion, and I give it to moderator to continue of the program. Thank you.
Thank you, Bang Arya. Thank you for summarizing everything from the points of view of the government and the national strategy, because everything has to be integrated, including with the government policy and whatnot. So we have about 15 minutes for the question and answer session. And I have collected a few. I'll just read them. Some of us ask multiple questions, but because our time is limited, I'll just like pick one, if that's okay for all of you. So the first question is for Pak Yan. I'm Sarju from Universitas Gadjah Mada. Great explanation, Pak. What control the distribution of hydrocarbon? Why some structures only contain oil while some others contain gas, only gas?
So can I answer directly?
Yes, sir.
Yeah, thank you. Thank you, Pak Sarju, for the question. It's very interesting question. Yes, there is two questions. Basically, one is the source rock analysis. Yes, we did a lot of study on that. And as we know that the region for our PSA is basically charging from Bawah Graben, which is there is a Sin Reef source rock there that can expel both oil and gas. The second question, what controlling hydrocarbon distribution? There's few things that I can answer. First is the source rock itself. They can produce both of them. The second one is more to be like trapping mechanism. As you know that there is a balance between seal capacity and buoyancy pressure. As you know, the gas is more movable versus oil that is less likely to migrate further away. As well as the timing, the oil is generated earlier and then gas formed later on. So the old trapping mechanism is more favorable to oil, while the young more favorable to gas, and that is based on our observation nowadays. The other thing is probably more to be a migration pathway. As you know that the back to the buoyancy pressure, the gas column, when it is very high, can break the seal easily and then move it to the younger sediment. And that's sort of factor that really govern the distribution of the oil and gas. If you take a look in the block B in general, we see that the oil more to be trapped deeper rather than gas. And this is explaining that the gas more movable feature can easily migrate toward the peak position where the seal capacity is really less. So that's why it's kind of sophisticated, but scientifically can be predicted. I think that's probably the answer to the question. Thank you. I hope it.
Thank you, Pak Yayan. Thank you.
Okay. Thank you, Pak Yan. Let's move on to the next question. This is for Pak Eko Wibowo. My name is Eko Bayu from Universitas Jenderal Sudirman. My question, regarding the migration, the reverse fault looks like sealed. So the migration only by a juxtaposed sandstone, or there are other ways to migrate?
Can I answer directly? Okay.
Yes, sir. Go ahead.
Okay, so I think you're referring to, thank you for the question. Yeah, I think you're referring for the northern area. Yeah, maybe Pak Budiono will answer better than me, but I try to answer. Actually, what we observe in the West Natuna, the migration is not always true faults. Yeah, you can see also from the West Natuna Basin that it's migrated to micropores when the seal is breached, so it's could directly migrated to the north. I mean the upper part of reservoirs, something like that. So it's not always true false.
Thank you, Bapak. How about we go with the next question from the same person? The second question: have you tried using the residual gravity for the preliminary exploration of the trap? Because from my experience, it is so useful to identify interesting area.
Okay. Yeah. Actually, in this East Natuna Basin, the issue is not a trap because it's a huge traps and most of them are drilled. Yeah. And also, of course, there's a lack of infrastructure. We need to find a huge structure. So if seismic already there, then it's already identified. I think it's sufficient enough to locate where's the trap locations. But maybe gravity will help. But I think from current seismic is already clear enough to map the structures. Thank you very much.
Thank you, Bapak. Okay, now let's move on to the next question. This is from Albertus Erlangga Cahya Pradipta, which is a YouTube audience. Interesting. Are the CO2 in Natuna single origin? What is the best way to predict the distribution of CO2? I think this is like a kind of like a general question where everyone can just jump in.
Yeah, Okay, I think I can help you with the prediction. I think I already shown in the presentation. We see some of the feature in the seismic in the eastern Natuna and what Paiko mentioned about the Christmas tree, and yeah, we see correlation between the high CO2 with that features. So basically, as I mentioned previously, we need to have a good 3D to be able to figure out the distribution. In terms of the source, I think some of the authors mentioned about the presence of carbonate that heating. Some of the authors also mentioned about the mental, the other source that CO2 can come out. So yeah, I think the CO2 is one of the problem, but in terms of the predicting, we have a way out to predict which one is the higher CO2 place and which one is we expect it to be less CO2 content. Yeah, I hope that's answered the question.
Thank you, Bapak. Before we move on to the next question, I just want to remind you guys, please check the chat box because there's a link to what absency. I don't know exactly how to translate that, but you know what I mean. So please check the link in the chat box. Okay, the next question is to Pak Budiono. This has been addressed actually in Mas Arya, I think, but Pak Budiono, please feel free to give your insights. A great and proud of history of the Premier in Natuna Basin, how P, I think Premier stands for Premier, would develop tuna discovery domestically by building facility in the Natuna Island, or just tying it to Block A facility or even to Vietnam. Hopefully P would develop it in the best way.
Sure. Well, thank you for the good question. I think, again, I keep mentioning, but now exploration is has changed. I mean, it's not just finding where the structure is, where we drill it, and all the stuff. Finding the gas and oil it doesn't stop there. So it's basically you have to think even earlier, much earlier before you put your wells, you put your drill bit there. So in that case, for the tuna development is similar. I think we have something in mind even before we drill the exploration well. And certainly once we have that prospect drill and discover the gas, discover the oil, we certainly have to mature the plan itself. Well, certainly it's not just us, it's involved a lot of parties, including our commercial team, special commercial team, I mean, to find out where the market is and then how we're gonna commercialize this. And once it's fixed, then what is, come up, what is the market, then yes, the following work will happen. And certainly with tuna itself, I think the current view is that we will actually send this gas to Vietnam through one of the field that nearby, actually, I mean, just across the border. So there's a pipeline that we can connect to the Vietnam buyers. We don't need to spend a lot of money, basically, I mean, to build a pipeline or something. So that's the current plan. But the answer is always there. I mean, when you are coming to building a business with somebody else new, I mean, we still need to have, test the water as well. I mean, the HOA, the unbounded HOA has been very much there. But again, this is the next level of the commercialization. So the finalizing the HOA with the Vietnam government, especially, this is going to be quite a critical point, I mean, for this project to move forward. The idea of having, transport the gas back to Natuna, big Natuna Islands, or even to WNTS, that's been assessed as well. But again, I mean, looking at the cost benefit of the of this project, it seems that the most economic way to go this, I mean, basically through the Vietnam's market in the West Natuna Besar is not there. I mean, unless we have a power plant actually built in that islands, and then we build the grid as well. I mean, to sell the power somewhere else. I mean, probably exported it, but we don't know yet. I mean, that's not part of the equation now. I mean, the current plan is actually selling this to Vietnam. WNTS, like I just mentioned, 400 kilometers, $500 million investment. That's not going to make any, economic development for this field, basically. Thank you.
Thanks, Abang, for the answer. So the next question is from Mas Nugrahanto. Question to any of the presenters, please. Given the topic is about gas in Natuna, how about the oil prospectivity? Any chance of developing enough oil more in these basins while waiting? I guess waiting for the gas, maybe. Please feel free to jump in. Anyone who want to share their insight? Not at the moment. Probably we can just hold this question. Or Pak Yanyan?
Yeah, maybe, yeah, we still have some of the oil prospect and even oil undeveloped discoveries in Block B area, and I think currently it's just a strategy of the prioritizing what we have. So basically the gas price is really good, so maybe that's probably the one that prioritize at the moment to to develop more gas. But certainly the oil prospecting is still ongoing, and we see some of the oil potential in the region as well. Yeah, I hope that answered the question of Pak Kuntadi. Thank you, Pak.
Yeah. Thank you, Pak Yanyan. And let's move on to the next question. This is from Pak Andang Bahtiar to Mas Budiono. How do you feel the startup of production activity in tuna might further induce the overall reactivation or revival of Eastern Natuna Basin ENP? What else needed in terms of policy/regulation for that purpose?
Big question, as usual, Anand. First of all, I will answer the first question. I mean, how this gonna reactivate, revive, basically the East Natuna Basin exploration and production. Well, I think we have a quite good history in the West Natuna Basin. I think back in 2000, even earlier. I mean, when we talk about the POD since 1997, 1998, I think at that point there's no way we can develop gas. I mean, for like 500, 600 kilometers away, back to our buyers in Singapore. By having this consortium, not Block A, Block B, CACAP, I think that synergy proves that we can actually develop even from this remote area to the buyers, to their door, basically directly, and then generate cash flow, generate profit for the operator, as well as giving a good return basically to the Indonesian government, billions of dollars. That's hard work. I mean, we have to honor what respect to what our predecessors in this case, or previous engineers, previous geoscientists, by having this a long vision that there's going to be something for us, something for them, something for the Indonesian government, and that's realized that's happened, and then it's still happening, and it's creating a lot more values. So in that case, synergy is the words. Here it is. So by having this tuna development in the East Natuna, certainly I think this creates another potential synergy. I mean, as you can see that we've been operating through Matak Island in the for West Natuna. But I mean, for this tuna, if this develop, then Natuna Besar is going to be our next base for the operation. So in that case, the airport is going to be prepared, the warehouses, the docking for the vessel and ships, and all this stuff is going to be there. And then if things coming, I mean, for the other operators, that could be synergized, and then certainly that will create some sort of cost efficiency and operating efficiency as well. So that's from perspective of synergy and how can it actually triggers. Again, I mean, like I just mentioned, we might need to develop as well as the liquid handling facilities in this area, and then that will not fill forever. And certainly that could be actually synergized as well, just in case someone finding oil in neighboring blocks, in neighboring fields, that could be synergized as well. So those kind of things actually we learn from the history, and then we will continue again with this, in the future as well. Scientifically, I think we learn a lot. We can exchange, and I like the idea of having everyone actually here. So you're sharing the ideas, not just about the subsurface part, not about the just exploration side, because like I said, when you are proposing a well now for exploration, the management is not just asking what is chance of success. They will ask how much money you will get. You will give me, by drilling the well, if this is successful, if this is not successful. So it's been quite big and complete pictures we need to provide. So similarly, I think we need to have this basically in mind that yes, I think we can share things. So I like to have this forum, and probably we probably need to continue. If we want to revive the the activities in the area, well, at least from our side, from the beginning, from the explorers, see what we can exchange ID and all sharing the information and stuff like that in more regular basis. That's kind of idea that we would like to have as well. So the further question Pandang is asking about the policy and regulation. Certainly, that's a different question to ask, because personally, I'm working for the contractor. But if you are asking for my personal opinion on this one, so in terms of exploration, my view about exploration, my vision about exploration is what we call just right. What just right meaning that the prospect that we need to drill need to be just right in terms of size, chance of success. All you guys know about that, exactly what it is. The investors need to be just right as well, meaning that big investors is not looking for small things. We've been exploring Natuna Block A for decades, and then the big structures have been drilled. Well, I saw some big structures that not been drilled, but again, it's because they turned that down because of they put a lot of lower chance of success and stuff like that. But if you have the fund, then somebody will drill it sometime better. But it still needs to be just right, just a right prospect for the right investors. The other thing that we need to have actually a just right policies as well, like Pandang mentioned. What exactly just right policy? In my opinion, I think every basin is kind of like unique. And then we have the Indonesian government in this case needs to be smart, telling everyone, have a thing analyzed and see what kind of investor will be, interested in this block because of the prospect is like this, the size of this, the size of the investment like this. So they need to know about that as well. And then we, as the Indonesian government, we also need to know their capability as well. It's not prospect is not for everyone. Prospect is specific for a specific investor as well. So in that case, we need to make sure to make it happen. It's not just real finding a resource, not necessarily developing that and become a research. That's going to be difficult if you don't have that, a screening policy at the beginning as well. The other policy is actually about the funds. Of course, I think we've been contributing to the Indonesian government quite significantly. Pandang, in this case, in the last 2 years itself, the Indonesian government probably received around $350 million, probably around that ballpark a year. So if we can have something in return to our exploration, for sustainability about the program in the area, that will be helpful as well. I think that's just some of the idea about the my thought. But again, I'm very happy to discuss offline Pandang if we have any other time while we are having a coffee or something like that. Thank you very much for the question. I think that's a really interesting question. I would like to have more discussion on that one as well. Thank you.
Thanks, Bang Budiono. This is probably our last question because we are out of time. This is from Rosie Andi Saputro. Sorry if I mispronounce your name. From YouTube audience. This is to Pak Arya. Would you please share with us the strategy related to political issues, geopolitical issues, from the GOI to firm our position in the certain area on the East Natuna Basin? This is probably related to the 9 dashed line. Go ahead, Bapak.
All right. Thank you. Very good question. And this is the recently issue that already arise since the China release about the 9 dash line that claim part of Natuna area become their authority. And before I answer about the question. For me, I like to add information from Pak Andang that okay, Pak Andang, that's a very good question regarding about the strategic how to develop the frontier area in Natuna Basin, especially in East Natuna. Yes, maybe in terms of the contractor view, Pak Budiono already explained about the strategy regarding of the investor strategy. However, in Indonesia, as a part of a government of Indonesia, as Kakamigas, very encouraged for the investor. Probably if you have something issue that should be need to have, I mean that need help from government of Indonesia. So please propose, maybe Pak Budiono propose to us about what the kind of like stimulus to push or to accelerate the production of from tuna. And of course, recently we cannot play with the common practice of the oil and gas industry, and of course we need to have a further action and because this is related with the question to me, especially about the geopolitical strategy, because not only tuna, and of course we have Natuna de Alpa and North Sokang field, and there are of field is our responsibility to have existency of government of Indonesia. That's why normally if we have discovery and probably economically very good, so government of Indonesia will support all of you if you have something need stimulus, please propose to us. And I don't think that we can sit together and discuss what type of your list and probably we have some way out to accelerate that production. And maybe we can say that currently Medco already discussed with SK Kamigas, and they propose because of they have like a marginal fit. So we need to adjust like a fiscal term, especially in the particular field. So we can accommodate that kind of the strategy. And if what I can say that if we are as Kamigas of Indonesia, government of Indonesia already help for the western area, like in the Medco and the western area of Natuna, and of course in the eastern Natuna, which is geopolitical issue are stronger than the others. So for accelerate the production, of course we will fully support for any kind of proposal from the investor. I think that's all, Pak Hanaga, for answer the questions.
Thanks, Bang Arya. Turns out we actually still have time, so I changed my mind. Let's go ahead and continue the question. The next question is for Pak Amir. How is the reservoir heterogeneity in that gigantic macro closure? Is the porosity that high all over?
Yeah, I think it's a very good question. Obviously, you cannot have the 7 Darcy sand on 20 or 30 square kilometer. That is a given. But what we know is, and we have drilled now several wells on the closure. What we know is that the minimum permeability on anywhere on the structure in the main sand does not go below 1 Darcy. So you are looking at a sand which is above 1 Darcy, above 30% porosity. So then there are some facies which are even lower than this quality. But then again, you are talking about 300, 400 millidarcy. So for a gas reservoir, it's phenomenal. It's very high quality. So it will work. So even in the lowest quality facies, it's a very good sand because it's loose sand, is very young. It has not undergone diagenesis. It has not undergone a lot of compression. So for a gas play, it is very good. And it is sheet-like sand. So coming back to the heterogeneity, it's sheet-like sand. So it is not very heterogeneous.
Thank you for the question, for the answer, I mean. So how good is the correlation between the seismic attribute, for example, versus the data pulled from the subsurface, from the core?
Very good.
Yeah.
It's very good because it's shallow, you can utilize the seismic. You can do very nice inversion work on the seismic and correlate it with the log data. When we acquire log data, we make sure that we acquire good sonic logs, geophysical, all the logs, including image, correlate image with the cores. One interesting thing is, although the sand is loose, we have a 70 feet whole core, conventional core. So we are not talking about plugs, we are talking about a conventional core. We have a 70 feet core in Muda formation. And when you have our core, when you have the real rock, you learn a lot from it. That is the real stuff you're talking about. So yes, when you integrate the seismic with the core well data, you get a very good, strong sense of where the sand are and what the quality is and the distribution. So high degree of confidence.
Thank you. Now I'm curious about the core. Must be really amazing. So let's move on to, this time is probably the last question. This time is for real. This is from Firdi Kusuma. How many risk of investment when we developed the East Natuna gas, current and future condition, Pak Budiono? This is for Pak Budiono. And then in such area claimed by China, 9-dash line is a geopolitical affected by some plan and strategy ahead of this condition. Consider some of the potential resources around it. And this is for like everyone. Feel free to jump in. We have about like 5 minutes probably.
Okay, I suppose the first question, the risk of investing in the East Natuna, especially in the Tuna area. Well, as you can see that not all the East Natuna is actually claimed by that 9-dash line. So it's only part of it, probably just on the tip of that corner, basically, that was claimed. Certainly for the rest of the area, no problem. I think you can invest. I mean, it's just, again, I mean, like I keep mentioning, I mean, it's about how you view the development itself. I mean, considering the high CO2 and all this stuff. Well, the technology is there, but the problem is it's requiring huge investment as well as defining the market first. So that's one. Secondly, I mean, specifically on Tuna area, where it is claimed by somebody else as part of the territory. Well, I think we rely really on the Indonesian government, and then because we believe that this Indonesian government is strong enough, and then will defend behind us. So that's why we were confident to jump in and invest in that area. The fact is, we have already spent like more than $200 million actually on the wells. I mean, to develop it, to explore, to discover, and to appraise as well. Well, the next investment coming is even bigger, $1 billion of investment. I mean, to develop this. So without a belief into the Indonesian government, then that will not happen. But again, we're looking at the current position. I think we have that small friction with their Coast Guard, but I think it still can be managed somehow, meaning that our existence there is actually quite acknowledged by them as well. So they bother us a little bit, but they eventually back up by themselves. So in terms of how much risk, I think the risk is always there. But again, we truly believe that yes, I think we are saving on best to invest in that area. That's all from me. Thank you.
Thank you, Abang. So that would be the last Q&A session. I'll give a really brief summary about our talk, and then I would like to invite all of the speakers to give a closing remark, probably like a few minutes, really short. So the premise in today's topic is how to kickstart the creaming curve, right? That's already flattened. And we happen to have lots of proven, undeveloped, or stranded discoveries, including shallow gas from, for example, the Indramuda formation, and also the alpha from the carbonate, which is really, really high, 222 TCF reported, but the CO2 is really high too. And also the Natuna case, where you have the political and also technical boundaries. And also we have new plays, which are much more risky, like the stratigraphic trap, basement drapes, and then basement fractures. And then wrench plays, I don't know exactly what that is, but it sounds like pretty dangerous. But anyway, so in order to configure the gas exploration and production in Natuna, to bypass all of those obstacles, we need, first of all, incentive, right? Because the operation itself is very risky, probably from the government. And then we have to get around the one of the main challenge, which is the CO2 content. And there are many ways, for example, via carbon sequestration, or just blend the gas and just sell them like Malaysia. And also, we also need cutting edge technology, for example, how to core a loose sand. Turns out you can freeze it, which is really cool. And probably the last point is the political obstacles. And I really agree with someone who said in the chat, we need synergy, like a collaboration between the government, the people, the companies. So that's about it from me. Please, once again, each speaker deliver your closing statement, probably a few minutes. We can start from probably Pak Yan.
Okay, thank you, Nagaya. From exploration standpoint, I think the Natuna is very interesting area. Yeah. It has been produced a lot, but yet to find is probably still big as well. So, as you know that if we are playing in the one area, one major area, we need to have new ideas, new perspective, new approach, and this sort of thing can be able to see that the one that missing in the past. I just copy one of the big discovery in North Sea, operated by I think the field name is Johan Sverdrup. It has been quite a while. I think some of the major operator operated there as well, but then suddenly somebody with the creativity can found a giant discoveries there. So the nature is complex. God created it very complex, but we need to understand more. I think that's probably the message from me. Thank you very much.
Terima kasih Pak Yan. And then the next is Pak Eko Wibowo.
Okay, thank you. Yeah, I'll talk about East Natuna itself. I'll try to steal first the statement from Pak Budiono and Pak Andang Bahtiar. Synergy, I think, is the most important things. Yeah, like Pak Budiono mentioned before, in West Natuna, when there's no pipelines, but because of synergy, it could produce now until now and become one of the main producer in Indonesia, I think. So we can apply the same things in the East Natuna. So if we could synergize, of course, with the government support, yeah, we can start in East Natuna. And the other things is actually the CCS. I think is the one of, in my personal opinion, is I mean the best place, one of ideal place to apply the CCS technology, because reservoir is there, the reserve is there, is huge resource. In Malaysia, as we know, this already start the Kasawari project. Why don't we start in Indonesia? I think if nobody start, then who will start? Thank you very much.
Thank you. And then the next from Pak Amir Mahmud.
Yep, thank you. Two major aspects. Number one is I completely agree with Pa Yan and Pa Eko. Synergy, and the second term is collaboration. We have to learn from each other. We all have our expertise. As Pa Budiniano said, they have a lot of experience. We can work together to untangle the complex issues. Support from the government is also important, but as the operators, technology and technical knowledge sharing is one thing. It has always been a problem in the oil and gas. Technical sharing is missing. Data sharing, knowledge sharing is missing. If we improve it, we will help each other a lot. Second thing is, as I said in my presentation, there is this terminology that we should think out of the box. That is an old concept. Now, in today's world, there should be no box. There is no box. You have to be careful of your biases. When you are looking at the data, are you thinking the same way that the seismic interpreter was thinking 10 years ago? For example, in Natuna, or you are looking with a fresh pair of eyes. If you start looking with a fresh pair of eyes, you will find still opportunities. I strongly believe in West Natuna, there is still gas and oil plays. Significant amount of oil and gas plays is still there. So just be careful of your biases, and once again, increase collaboration. Thank you.
Thank you, Pak Amir. And the next is Bang Budiono.
Thank you, Pak Hanaga. I think if people said, the millennials said the Superman is dead, I don't think that's happening to Natuna. Natuna is not dead yet. So it can survive. It can even, grow bigger within our hands. My hand, your hands, and probably I'm looking as well that there's some, audience from university as well. I mean, yeah, I think they need to an encouragement as well that this is part of the world, part of the area, part of the your country that can be further exploited as well. So it's not there dead yet. I think we've been producing for decades, but it's not there yet. I mean, I believe there's still a lot of potential that we can explore. Yeah, of course, there are problems here and there, and you need some support financially, politically, and that's all need to be in line. So my last statement, I think, let's continue the exploration. Let's work together, like Amir said, and everyone agrees on that one. Let's create something that can actually we can contribute to this country, especially as the Indonesian nationals. thank you very much. I think hopefully everyone can get a big success in the next few years in exploration and development in the area. Thank you.
Thanks. And our last speaker, Bang Arya, please.
All right, thank you. I have several big notes regarding our discussion today, especially number one about the development scenario. I emphasize in the Eastern Natuna. Yes, we should have like which one the best development scenario because of very rare, or maybe there is no infrastructure over there compared to the Western area. So what I can say is, okay, let's sit together regarding to create our planning of development scenario, and also maybe the investor needs several help regarding of incentive because of very frontier area in the Eastern Natuna. We government has should have uncommon mindset to accelerate or invite the investor in Eastern Natuna. And the other thing is because of a geopolitical issue, of course, this is the one key point that there is no reason for Indonesia to have existency in the border area because of there are many activity, as mentioned with Pak Budiono, that there are many of Coast Guard from China during the drilling of tuna. So as a part of government of Indonesia, SK Kamingas very fully support for development or a development for the discovery field in the Eastern Natuna, and also for CCUS. Yes, this is a very hot discussion, but in my personal opinion, if CO2 management only as CCS, like storage and just CO2 storage, this is one of like critical economic value for development. However, if we conduct CCUS not only as a storage, the CO2 can be utilized for the enhanced recovery for the field. Probably this is like additional benefit for CO2 content in several area in the Eastern Natuna. I think that's all from me, Pak Hanaga. Thank you.
Terima kasih, Pak Arya. So before we end today's forum, we would like to invite Pak Andang Bahtiar as the founder of ISPG to give a closing statement. Go ahead, Pak Andang.
Okay, thank you, Pak Naga. Everybody can hear me?
All good.
Okay, good. Okay, thanks a lot. I'm really proud to, although I was late to jump into this meeting, but I'm really proud that the ISPG has become this so professional, so that, we are talking really deep into technical things related to something very important strategically energy area in Natuna, especially talking about East Natuna, which until today we have 50 years discovery history of East Natuna, the alpha over there, and nothing happened until today. And then I think what has been done here by ISPG need to be kept on being, warmed up and then heated up, so that it's burns once again. Like every time we have a circle of this kind of things, when international condition heated up, like 4 or 5 years ago. Remember, everybody, that there is a dispute with China about this 9 baseline things, and then our president went over there with the LBP, the Lord Luhut went there also, and then everybody just excited about talking about this kind again and again and again, but nothing happened after that. Nothing happened, and even the tuna things has been 5 years now since I was there as the head of exploration committee of National Exploration Committee at the time. But I'm really proud of ISPG. If you guys keep on warming this up, because the energy is there, the strategy is there, and then the knowledge is there. I think I'm really proud of everybody here. Yan, Eko, Budiono, Arya, and also who else? The other one.
Amir.
Amir.
Yeah. Everybody has their own, their own perspective, deep, professional, and I'm really proud of you guys. And then for ISPG, for Julianta, please continue on, because I think if we just kept on being like this, and then that is put everything just having us satisfied with what we are talking about without necessarily moving forward, it will be nothing. As always, I always said to IAGI, whoever, IAGI or IPA or especially ISPG, please put everything in writing. And then give it to government. In terms of this Natuna, especially Natuna development, we have to keep it up. And then the second thing, I want to add something related to Bambang study question. Why government didn't push to build the pipeline over there? And then that's the basic question. We don't have any guts. So to have a guts, we have to have a synergy, and everybody have to have the same voices that this is very important for us to keep on exploring and producing in that very strategic area of Indonesia, which is Natuna Sea, what we call it Natuna Sea over there, or Northern Natuna Sea. So without further ado, once again, thanks a lot for everybody to keep on the good spirit of the technical things and also slightly political things. I like Budiono, especially his view about all of this big picture about how we go forward with synergy and all the things related to this. And also Arya, of course, as the representative from the government in the SKK Migas. Thanks a lot. Good luck, guys.
Thanks, Bapak. So, as the moderator of today's forum, on the behalf of the committees, I would like to thank all the speakers today. Pak Eko, Pak Budi, Pak Yan, Pak Amir, Pak Arya. I'm sorry if I keep calling you guys Abang, because that's out of habit, if you guys are okay with that. And we would like to thank Pak Erlangga and Pak Andang for the statement. So, should I give it to Mas Jupe or? Oh, just wrap it up. Okay. So that's all for today's forum. I am Hanaga Simabrata. See you next time. I wish you guys all in perfect health. Good afternoon. See ya. Bye.
Thank you. Bye-bye.
Thank you, everybody.
Thank you, everybody. Thank you, Pak Budiono.
Okay, bye-bye.
Everyone, cheers. Have a great weekend.
Oh, Pak Burhan.
Ya. Makasih Pak Aryana, Pak Andang, Pak Eko, dan Pak Julianda, para pembicara. Izin live, Hanaga.
Gimana, Pak?
Izin